Hi everyone, today we are going to demonstrate actual drug layering on sugar spares. So before start actual demonstration, let's see the requirement for this practical, means the formulation of the control release drug delivery system by using a fluidized bed processor. So as you know, there are many applications of fluidized bed processor, such as it can be used for the microencapsulation of a solid drug. Then it can be used for the coating, means the drug layering on specific sugar spares. Then the third use of this instrument is drying purpose and granulations. Okay. So this instrument is used for, as I said, the granulation. So the coating, then the granulation and drying and the microencapsulation. So these are the most important applications of this fluidized bed processing. Nowadays, this ABB processing used for the solubility enhancement purpose. Means by using this fluidized bed processing mechanism, we can prepare the solid dispersion of poorly aqueous soluble drug. So definitely we can increase the solubility of that poorly aqueous soluble drug. So these are some applications, most important applications of the fluidized bed processing. So for the today's demonstration, means we are going to coat the jug on this specific 425 micron sugar spares. So these are the a 425 micron size a sugar spares. Then this is the seal. This solution means hydroxypropyl methyl cellulose HPMC E5 grade. You can use for the seal coating of the sugar spares. Then after a seal coating, the drug layering we are going to perform. So this is the 0.5% weight by volume a drug solution in water. This is the aqueous solution of the drug solution, and after that we are going to coat the polymeric solution, means this is the release retardant, a polymer solution, HPMC K4M. It's a high grade, means high grade viscosity grade HPMC. So HPMC K4M, HPMC, you can use the HPMC K100M, Udrazit. So means you can use any release retardant polymeric material after the drug layering. So basic mechanism of this release means control release multi-particulate drug delivery system, you can say the MUPS. Okay, so as per the concentration of the polymer, means so this is the very important steps, means rate limiting steps in this multi-particulate drug delivery system is what? The thickness and the concentration, means the quantity to be used in the preparation of this polymer solution is very important. Suppose you are using a 1%, 2%, so as per the concentration, so drug release will be there. Okay, you are using only 5.5% drug polymer solution, so as per the thickness of a coat on the sugar spares, your drug going to release. So means a release mechanism is definitely depend on the solid content or the concentration of polymer. Remember, okay? So a seal coating is necessary to avoid or to prevent the breaking of these sugar spares in a expansion chamber of ABB. So that's why seal coat is necessary. Then the drug solution. So as per the here the selection of the solvent. Selection of a solvent is a very important steps in this process. Why? Because as per the BCS, as per the solubility of a drug, we have to use a specific solvents. Okay, so as per the solubility of this particular drug, we are using a water aqueous solvent in the preparation of this solution. Okay, see, sugar spheres 425 micron, 0.5% weight by volume HPMC A5, then 0.5% weight by volume drug solution, and 0.5 to 1% a polymeric accord. So before start the actual process, see the standard operating procedures. What is the standard SOP while using this fluidized bed processor? Before process and after process. Okay, so let's see one by one steps. The first step is open the tri-clamp closure at the material container. Then hold the material container along with the bottom part and open the tri-clamp closure at the processor inlet. Charging the content or the charging the material in the chamber is a very important, or the adjustment of a gun and nozzle at the point of nozzle point. Okay, so you can see here, this is the gun, spray gun, and the size of this gun is a 0.5 mm. That is the orifice of this gun is 0.5 mm. So again, the selection of a gun and selection of the orifice is based on the particle size, the molecular weight of material, molecular weight and particle size of the jug. Suppose the jug has larger size, so it will difficult to pass through this 0.5 mm orifice. So therefore, this step is, that is a selection of a proper gun and selection of proper the size. Now see, in Worcester process, in microencapsulation, Worcester process is there. So why it's called as the Worcester? Because the gentleman Worcester scientist developed this microencapsulation technique. So that's why called as Worcester process. Nowadays it's called as the air suspension, or sometimes a mechanical process for the microencapsulation. Okay, now the position of the gun. Okay, position, bottom spray and the top spray. So based on the position of this gun, the mechanism will be on. Okay, see, you can see here the top spray. When you are going to perform this operation by top spraying and the bottom spraying, here the upper pipe you can use for the air, means atomized air supply. It's a very important steps. Okay, for top spraying, upper pipe you can use for the air supply, and the next pipe, okay, liquid supply. Same, a bottom spray, the upper pipe you can use for the liquid supply and then air supply. Okay, remember, bottom spray and top spray. Suppose, see, as per the applications, as I said, can be used for the encapsulation, coating, then solid preparation of solid dispersion and the granulations. Okay, so the bottom spray, suppose you are going to perform or formulate this type of multiparticulate or drug layering, so you should follow the bottom spray. Remember, bottom spray. Suppose you want to perform the solid dispersion or the granulations, so you should follow the top spray. Okay, for the preparation of granules in FBB, you should follow the top spray mechanism. For the drug layering, for the preparation of multiparticulate drug delivery system, you should follow the bottom spray. Okay, remember, difference in between top spraying and bottom spraying. Okay, so you can see here, this is the position of a gun at bottom side. Okay, and here you are using a demo, okay, instead of gun position. Okay, now how to charge the material in this chamber. Okay, so therefore we need to optimize the process variables of this instrument. Every instrument we need to optimize the variables, parameters, those parameters which is directly affecting on the product characteristics. So what are the different variables of the fluidized bed processor? See, the first parameter is the inlet temperature, then second the product temperature, then atomization air pressure or atomization air supply, then fluidized pressure or airflow control, airflow pressure, then flow rate. So these are the some critical elements of this FBB. Inlet temperature, suppose increases the inlet temperature from 30 to 70. So during this 30 to 70 degrees Celsius, definitely this temperature may affect on the product characteristics. So how to decide which is the suitable inlet temperature, product temperature and the flow rate? So as per the characteristics of your coating solution and the drug solution. So before choosing this instrument for the formulation of particular drug, we need to know about each and everything about the drug. Means physical characteristics, chemical characteristics and mechanical characteristics of your drug. So suppose your drug is highly sensitive to heat, so we can't use this instrument of the process for the formulation. Okay, thermolabile substances we can't use. So means definitely here the temperature is increases. So if you increases the temperature, so your drug will be degraded. Okay, so product temperature, flow rate. So here see, we can observe the difference in between HPMC. Two types of HPMC grades are different. Okay, so this HPMC is a E5 and this HPMC is a K4M. Okay, so difference in between these two HPMC means viscosity is different. So as per the viscosity, we need to optimize the flow rate in RPM. Okay, 1, then 1.5 to 2.5, then sometimes 3 or 3.5. Some switches over there. Okay, reverse, forward, then this is the on off switch. This is normal and maximum. With this knob is a fine adjustment, and this is for the coarse adjustment. Okay, reverse, forward, on off, normal, maximum, coarse adjustment and fine adjustment. First fine adjustment we have to use, and then the coarse adjustment. Okay, now पॉज करा रहे हैं. For the seal coating of 14.5 degrees Celsius is the inlet temperature. The product temperature is 35. Purging on time is 3 millisecond. Purging interval 3 seconds. Means after every 3 seconds, for 3 milliseconds the purging. Okay. So what is the use of purging? So in this process definitely the dust will form. So absorb means this filter. If here the thin filter is there, so this filter will absorb the excess dust. Okay, so this is the use of purging on time and purging the inlet. Now, so with this knob you can adjust the fluidization airflow, fluidization air pressure, and the atomization air pressure. We can see here when you decrease the atomization air pressure, so the flow pattern will be uneven. Okay, uneven. Okay, like this. And now this pattern is called as the Ooster pattern. Okay, like this Ooster pattern. Okay. So here there are about 1 to 1.5 bar pressure atomization air control. And this atomization air pressure also used to break the liquid molecule into a smaller droplet. Okay, smaller droplet, and the flow rate is at 2.42 rpm. So after that, so drug coating, drug layering, and then polymer coating. So first step is a seal coating by using HPMC E5. these are seal coated granules HPMC E5 on a sugar spheres. These are drug loaded spheres, and these are the final formulation drug loaded with a release retardant polymeric material, that is HPMC K4A. These spheres contains sugar spheres 425 microns, drug solutions, and final coat is polymer coat, that is HPMC K4A.